Hello guys, welcome back to my channel Algorithm Minds. My name is Hassan Khurram, and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach theoretical concept as well as practical programming skills in data science, data analysis. So if you're a person who wants to learn programming from scratch, I request you to subscribe my channel and hit the notification bell icon button. So I have been publishing a series of tutorial videos regarding marketing analytics, and I have taught you about how to perform data visualization in terms of marketing analytics, and I also discussed some statistical aspect for this topic, marketing analytics. So for today's video, I'm going to discuss about customer lifetime value, which is again one of a very important topic when in terms of marketing analytics. So what is the actual business problem behind this value, customer lifetime value? So suppose an online company would like to know each customer lifetime value for 6 months, and we will utilize one of the buy till you die model, which I'm going to explain to you in a moment in this video. So stick with me till the end. So we will use this model for predicting the purchase amounts, and then use a statistical model which is called gamma model to predict customer lifetime value for desired period. The desired period in our case is actually 6 months. We will utilize the lifetime module of Python library to create our unique data set that will actually we will use module lifetime that will create a unique data set that has some unique values, which I'm going to discuss later. And using that data set, we will predict customer lifetime value. So you might be asking like, okay, what is customer value? What is customer lifetime value? Or customer value or customer lifetime value is the total monetary value of transaction purchases made by a customer with your business over his entire lifetime. Here, take an example of the calculation of customer lifetime value, which is equal to the average sales made by customer, but then multiply by purchase frequency. How many times the customer is likely to had purchased in a given amount of time. Then we have churn rate, which is actually the rate where the customer becomes inactive, and then we have a profit margin. So an average sales is calculated by total sales divided by total number of orders. Purchase frequency is calculated by the total number of orders divided by total unique customers. Retention rate is the total number of orders greater than 1 divided by total unique customers, and churn is equal to 1 minus retention rate. And then we have a profit margin, which is different for every different business and model. So that being said, this kind of calculation looks quite easy to do, but in exam we are assuming profit margin for each transaction to be roughly 5%. But the problem arises when we actually want to calculate customer lifetime value for an individual customer, instead of actually having one value for all the customers. So there are a number of models that we can use, or approaches. We have historical approaches and we have predictive approaches. So in today's tutorial, we are going to discuss about probabilistic model here. That being said, enough with the theory jargon. Let's move on and actually discuss our practical programming section. So first of all, I'm going to import important libraries. The very first important library is lifetime, that is actually help us to calculate some specific values based on the transaction data. Then that specific values will be used by our model to predict the customer lifetime value. Then we import pandas, numpy, datetime, sdt. Then we also import matplotlib and cpond. So in order to do data visualization for marketing analytics. And finally, from lifetime module, we are going to import the library. We are going to import the model beta geofitter, and we are also going to import a class gamma filter. And we are also going to import min max scaler. That being said, we will import some plotting functions from the same module lifetime. When the plot we are going to use is called plot probability alive matrix, which I'm going to show you in a moment. So that being said, then we are also setting the rows and width and size of our display as well. So the first thing we are going to do is actually going to import our CSV file. For this purpose, we are going to use this method reads underscore CSV or panda data frame, and we pass one input argument, that is the name of the file. Once we done that, let me just run this block of code for you. So this is the data we are going to deal with, and we will use it to calculate the customer lifetime value. We have a column of invoice number, we have a column of stock code, then we have a description like what was the actual product that was being sold or bought by the customer. Then we have the total amount, quantity, like how much amount or how much quantity of that specific item was bought. Then we have invoice days, which is important to us right now because in customer lifetime value calculation, we tend to calculate the frequency and some other parameters, which I'm going to discuss in a moment. Then we have unit price, like for what was the unit price for each unit sold. And then we have customer ID, which help us identify the unique purchases made by the customers. And then finally we have country column, which actually help us identify, oh, this customer belongs to this country. We will use df.info method, and we will roughly look at the data set that we have. These are the columns, and we also see their data type. We see quantities and integers, and other ones are object, and unit price and customer ID are float one. So, and then we will use df.describe, and we can actually see the two important thing we can actually see is the quantity and unit price. So right now we can see that the mean value of quantity sold is 8 units sold by average amount, okay, mean amount, and the unit price or average unit price is $4.5, let's say. Then we have min max values. Obviously we can see that there is some outliers, there's some values that we need to actually work on in order to prepare our data for our customer lifetime value analysis. That being said, so in order to get rid of these negative values, and specifically you can see that the maximum value of quantity order is something like 80,995, which is again an outlier. This is not in our data, so we actually need to get rid of that data. So we are going to do some pre-processing before we actually do the customer lifetime value analysis. So that being said, the first filter we are going to apply is on column quality and column unit price. So here we are creating a mask, a filter, and we are creating condition that we are going to look for column quantity, and we are going to look for only those rows where we have value equal greater than 0. Then it creates a Boolean series, Boolean mask with true and false value, where the false value will be dropped from this updated data frame, and two values will be taken. So that's how we create a filter for this quantity, where quantity value should be greater than 0. In the same context, we have actually applied a marks for unit price or filter, where we will set a filter that unit price must be greater than 0. So only those rows from that data frame, and update that data frame by equating it to df as well. And we are applying the same analogy but with a different kind of command Python statement here. So basically what are we doing right now here? You can see that we have this thing called str.contains, and where we are applying this method to the column invoice number. So basically we are looking at the column invoice number, and we are looking at only those row value where we have actually C letter in it. Okay, so based on this filter, what it will do, it will create two values where we have C in letter in it, and false value where we don't have the C letter. And then we are using the negating operator, which actually turns the Boolean true to false. So it reverses the Boolean series here. So by doing that, we are actually creating a filter where we don't have any letter C in it. So that's how we are applying that filter, by the use of this negating operator, and then finally extracting only those values by using this mask here and updating it to the original data frame df. Once we done that, now the next thing we are going to do is actually we are going to drop on all those rows which have null values in it, and that in place is equal to 2 as an input argument, which actually is an actually, which actually it actually means that we want to do the changes to the original data frame instead of actually getting the new data frame. So we are actually applying that changes to the original data frame, so the original data frame will be updated. And yeah, when I forget one thing, that n is equal to false, it means that when it finds some null values in that column invoice number, it will returns a false value. So that's what it means by. Okay, that being said, now coming back to the problem here. Now you can see that okay, we get rid of negative values in the column quantity and unit price, but what about these positive values that are outliers? So we need to actually get rid of those values as well. So we can get rid of those values by applying the methods of quantile. Okay, so it's quite easy to do, and I will help you understand this following two functions. It's not a rocket science, it's quite simple to understand. So we have created a function called find boundaries, and its function is to actually find the quantiles, or the upper boundary and lower quantity boundary of some specific amount. So, and that specific amount are taken in terms of quantiles. So those of you who don't know, have an idea about quantile is, so basically what a quantile is, yeah, exactly, it means that what percentage of your data set is above that specific value. So here we are creating two quantiles. The first one is Q1 is equal to 0.5, which is the fifth quantile, and we are also creating quantile 0.95, which is the 95% quantile for the upper boundary. So whatever the numbers that might be above this quantile, we are not interested in those number, and the same way. So okay, this takes two input argument. The first input argument is actually the data frame itself. The second input argument is actually the column name, on which what column you actually want to apply this method or functions. We have two columns, quantity and unit price. That being said, the other two remaining input arguments are the quantiles. Okay, so 0.05 and 0.95. Now once that function is called, what it will do, it will take that column, specific column. For example, let's take, we are taking quantity. In that case, it will find the fifth quantile of that column. Of all those values, it will find the fifth quantile value. In the same way, this upper boundary will find that 95th or the highest value, that is that on the 95th position. So it will calculate that value. Once we calculated that, it will return the upper boundary and lower boundary. Now we have also created a function called capping outliers. This is mean that we are actually getting rid of those values which are below than 5% of the quantile, and we are also getting rid of the values that are above 95% of the quantile. That being said, so we have created this function, and it takes two input arguments. The first input argument is the data frame itself, and the second input argument is the variable. And in that function, we are first calling the first function here, find boundaries, to get the upper boundaries and lower boundaries. Once we actually get those values, so after we have calculated the upper boundary and lower boundary values, so what we are going to do, we are going to use this Python statement here, which actually updates the column values of variable. Variable is actually the input argument we pass to this function. It could be unit price or quantity, and we are creating its value, and then we are using an numpy where function. We're using this np.where. So what does this numpy.np.where function does? It actually caps the value. It will find those values which are greater than upper boundary, and if it finds that values, it will create this value to the upper boundary value, which is the 95th percentile value. In the same way, we are again calling numpy np.where method, and we are searching for those values whose values are less than lower boundary. Once it finds that value, it will update the value with the lower boundary. That's why we are creating a cap of 95th percentile and 5th percentile. So that's what we do here in this Python statement. So we're going to call this cap in outliers function, and we are passing two input argument. The first input argument is the data frame itself, and the second input argument is the unit price. And then this in the second line we are passing input argument quantity. So let me just run this block of code for you. Now you can see that the outliers have been removed and our data is good to go for the customer lifetime value analysis. That being said, now the one more filter we are going to apply. We are actually creating a filter on the column country, and we are only taking those values where the country name is United Kingdom. So there we are creating a filter df.country double equal to United Kingdom. So that being said, we are only taking the values where the country, or we are only taking those rows where the country is United Kingdom. It's not necessary. I mean, you can continue with all the data, but for the simplicity of this tutorial, we are only interested in United Kingdom. Okay. Now you can see that our data contains only those rows where the country is United Kingdom, and we have unit price and we have quantities which have been capped by 95th percentile and 5th percentile. Let's move on and actually calculate an additional column which is called total price, which will be equal to the unit price multiplied by the quantity. So here I have created an additional column called total price. Now let's move on and actually discuss about RMF dataset. What is RMF dataset? How we are going to calculate RMF dataset by the use of lifetime library. So by using lifetime module, we are able to calculate RMF values. So RMF stands for recency, frequency, and monetary value. It is the model used in customer segmentation to analyze customer behavior and predict their future engagement. RFM analysis is commonly used in marketing to identify high value customer. Once the high value customers are identified by the help of RMF analysis, we are able to target certain high quality strategies with high ad spend towards that customer segment. So let's briefly discuss about what is frequency, recency, T, and monetary value. So frequency represents the number of repeated purchases the customer had made. For example, if a customer made a purchase on 3 different days, the frequency would be 3 since it had purchases on 3 distinct days. Then discuss about recency. Recency represents the age of customer when they made their most recent purchase. For example, if a customer made their first purchase on day 1 and their latest purchase was on day 30, the recency would be 29 days. T represents the age of customer in whatever time units chosen. If you want to choose weekly, if you want to choose daily, if you want to choose monthly, that's up to you. So for example, if a customer first purchase was on day 1 and the analysis period ended on day 50, then T would be 50 days. Then finally we have monetary value, which represents the average value of given customer purchases. For example, let's say if a customer spent a total of $200 on 4 purchases, then the monetary value would be $50 on average per purchase. For example, let's say imagine a customer that made their first purchase on January 1st, then made purchases on January 5th, January 10th, and finally January 15th. So let's move on and actually discuss about how we can calculate the recency. So recency, the time between the first purchase, which was actually the January 1st, and the most recent purchase is January 15th, which is equal to 14 days. So we have calculated our recency. The frequency is the customer made purchases on 4 different days. So the frequency is actually 4. T is the age of customer. If our observation period ends on January 20, then T is 20 days. Time from the first purchase to the end of the observation period. And now we are interested in monetary value. If the total spending by the customer is $400 for 4 purchases, then the monetary value in this case will be $100 per purchase. That being said, now we are able to we need to calculate these 4 values by the help of using a lifetime module and its method summary data from transaction date. And we are passing some input arguments. First one is actually the data frame, and the second one are actually the customer ID, which is the unique customer ID that helps us identify the unique customers in a given data set. Then we have invoice data. This is the date on which the purchase was made. Then we have total price, which is again the product of unit price multiplied by every unit price of a unit product. Then we have observation period end is we actually set a date where the observation period ends. So basically, if you recall that T, we have to define our T where the observation periods end. So here in our case, we have set it to 2011, 12, and 09. So let me just run this block of code for you. Now we have calculated this thing. The function from lifetime library generates a summary table from transaction data. The summary table includes essential metrics like frequency, recency, and customer age for the use in customer lifetime value analysis. So that being said, let's move on and actually see our data. So one additional filter we are going to use in our customer lifetime value analysis, or let's say this is our RFM data. So we are only interested in frequency where the frequency is greater than 1. We want only customers shop more than 2 times. So we are creating a filter here, only take those values where the frequency is greater than 1. That being said, here is the updated data frame we calculated from this Python statement lifetime and its method summary data from transaction data. So here is the RMF data set we have. For unique customer, we have a frequency, we have recency, we have T days, and we have its monetary value. Now we have calculated RMF data. Now we are good to go towards the prediction of customer lifetime value. So let's briefly discuss about BG NBD modeling for predicting number of purchases. So this BG NBD model is used to estimate the customer retention, how long the customer will be retained as a valuable customer to the company, and future purchasing behavior. It also defines the future purchasing behavior, like how many times the customer would more likely to purchase a product from you, making it valuable for companies that want to forecast customer lifetime value, identify which customers are likely to make the most repeated purchases. So again, this NBD model is used to predict how often customer will make repeat purchases based on their past buying behavior or based on their RMF analysis data set. So you are going to use this Python statement. We are initializing a variable named BGF, and we are calling this model beta geo filter, and then we are setting penalizer coefficient is equal to 0.001. So this here beta geo filter, this is the model from lifetimes library that implements beta geometric NBD, which stands for negative binomial distribution model, and penalizer coefficient is equal to 0.001. This is a regularization parameter used to prevent overfitting. Regularization ensures that the model doesn't fit closely to the training data set, or in other terms, it doesn't overfit, which might lead to poor prediction for unseen data. And finally, we will use this method fit that take 3 input argument. The first input argument is actually the frequency of the customer. The second input argument is the recency of the customer, and the last input argument is the T. Okay, so that's how this is the age of customer. Okay, by using these 3 input arguments, so 3 metrics, we are able to fit a model that using the customer data. Okay, now what actually we get out of this model? We actually get the output. We actually get a model that is able to predict the customer lifetime value. That being said, it gives us a summary. By using this Python statement bgf.summary, we are able to actually get a summary of the model, where the output of GH summary provides the parameter estimate and their corresponding statistics for beta geometric frequency model. These parameters are important for understanding the behavior of model and how it predicts the customer behavior. So the first one, the coefficient column, actually returns the coefficient of our interest. The first one is R, which is called the churn rate. Okay, the parameter R tells us how quickly customers stop making purchases. The smaller the R value, the higher the churn rate. Okay, so Since R is relatively high in our model, it indicates that the customer tends to stay active for longer periods. The second one is called alpha, which is the purchasing rate. This parameter alpha represents the tendency of a customer to make a purchase. A higher alpha value suggests customers don't make purchases frequently, but are retained longer when they do. Then we have the parameters of this model A and B, and the second column is called standard error column. Okay, how precise the estimates are. The standard error values, especially for R and alpha, are small, meaning that the estimates are fairly reliable. And then finally we have confidence interval, which is the uncertainty in the estimates. The confidence interval of R and alpha are quite tight, showing that we are confident about the value of this parameter, but the wide intervals of A and B means we are uncertain about this parameter. That being said, let's move on and actually plot our results. For this purpose, we are going to use this Python statement and this plotting function from the module lifetime, which is plot probability alive matrix. And after running this Python statement, we get plot something like that. On the x-axis, we have customer historical frequency. On the y-axis, we have customer recency. And this is the probability a customer is alive by frequency and recency of a customer. So this matrix is called probability alive matrix. It helps us understand users who are likely to return versus those which are unlikely to return. So x-axis represents the customer historical purchase frequency, y-axis represents the customer recency. Color indicates the probability of alive, like how much the customer is most likely to be alive. So based on this probability alive matrix, we are able to infer new customers, loyal customers. So the new customers are located in the bottom left corner, where we have low frequency and high recency with a high probability of being alive. Then we have loyal customer found in the bottom right column with high frequency and high recency. And if loyal customer do not purchase for a long time, they become a risk customer characterized by low probability of being alive. So that being said, let's move on and actually predict the customer lifetime value or expected number of purchases by the customer. So for this purpose, we are going to first of all define a time of how many days we actually want to make the prediction. In this case, we are setting it to 180, which stands for 6 months. And then in this Python statement, first of all, we are creating an additional column which is called expected purchase in 6 months in our data frame CLV, which already contains frequency, recency, T, and monetary value. And then we are using this trained or fitted model BGF, and we are calling its method conditional expected number of purchases up to time. And we are passing 3 input arguments. The first input argument is the T, time. The second input argument is the frequency of customer. The third input argument is the recency, and the last one is actually the age of customers. And finally, once we done that, we are able to actually predict the expected number of purchases by a customer based on our BGF fitted model. And in this Python statement, we are actually sorting the data frame by the column expected purchase 6 months in descending order. So the only top 5 highest purchases by the customer, expected purchases by the customer, will be displayed here. So this BGF dot conditional expected number of purchases up to time is a method from the fitted NBD model that estimates the expected number of purchases a customer is likely to make during the specific period time. Okay, so that being said, now let's move on and actually use that data which we have actually calculated by this fitted model and help us identify the expected lifetime value of customer. So for this purpose, we are going to use the gamma model, which can predict the most likely value per transaction in the future. So the gamma model is a statistical approach used to analyze and predict customer behavior, particularly focusing on how much customer spends, which is again the monetary value, rather than just how often they purchase frequency. Here there is an assumption before we can actually apply the gamma gamma model. The model we are going to use to estimate the customer lifetime value for our database is called gamma gamma submodel, which relies upon an important assumption, which assumes that there is no relationship between the monetary value and purchase frequency. And in order to justify this assumption, we can simply calculate the percent correlation of these two values by using this Python statement. So we are taking two columns, frequency and monetary value, then we are calculating the correlation between them. Now you can actually see the correlation is quite low, which is 0.08, which again makes this model, gamma gamma model, suitable for our calculation. That being said, at this point we can train our gamma gamma submodel and predict the conditional expected average value for our customers. So we are going to create an instance of gamma gamma filter class, which is a part of lifetime library used for modeling customer lifetime value. So we are initializing a variable named ggf, and we are creating an instance of the class gamma gamma filter, and we are passing input argument penalizer coefficient is equal to 0.01. This parameter applies a plenty term to avoid overfitting the model. So when we call ggf.fit, the model learns how frequency and monetary values are related. As you can see, we are passing two input arguments to this model. The first one is the frequency and the second one is the monetary value. The relationship helps business understand the spending patterns of their customer. This fit method uses these two inputs to learn the parameter of gamma gamma model, which describes how customer spending behavior is distributed based on their purchase frequency and monetary value. Now, once we have actually fitted our model with these two input arguments or two data of frequency and monetary value, let's move on and actually predict the customer lifetime value. So for this purpose, I'm going to initialize a new column in our already existing data frame CLV, whose name will be 6 month CLV, and we are calling ggf, the same fitted model that has been fitted with frequency and monetary value, and we are calling the method customer lifetime value. We are first passing bgf model, and then we are passing 4 input arguments, which are the frequency, recency, time, age of customer, and monetary value. Then we are setting time is equal to 6, and we are setting frequency is equal to d. So d stands for what is the frequency we want to do here. For in our case, we set to D, which stands for daily. Then we have finally discount rate. So this frequency D indicates the frequency of time unit being used here. Here D stands for days. So the calculation will be considered for 6 months as 180 multiplied by 30. And finally, we have discount rate of 0.01. This parameter specifies the discount rate used in CLV calculation. Our discount rate of 1% reduces the value of future cash flow to account for time value of money. This means that the future revenues are worth less than the immediate revenues, reflecting the opportunity cost of capital. Now, by using the Python statement here, we are able to calculate the customer lifetime value, and we are appending that value to the column 6 month CLV of data frame CLV. And here in this Python statement, we are sorting values based on this column 6 month CLV, and we are sorting in descending order. Now we can see that we do have a very high amount of customer lifetime value for some unique customers, as they range in thousands of dollars. So that's how you can actually calculate customer lifetime value by using this model, which is a probabilistic model. Now, finally, once we have calculated the customer lifetime value, we can actually segment those customers based on their customer lifetime value. So we can segment them based on their value. We can portion them into 4 quantities or 4 entities or 4 groups. We say that the hypernating ones are actually the lowest or the least profitable to the business. And then we have need retention. It means that these set of customers have a good potential if right market strategy is used for them. Then we have loyal customers, that these are customers more likely to purchase in the future. Then we have champions, these are the highest rewarding customers that the business is able to make the profit out of them. So in order to segment that customers, we are simply going to use this Python statement. So again, we are creating another column in our data frame CLV, and we are equating its value, and we are calling this method of panda data frame qcat. Okay, and it will actually segment the data based on it will update the value of segment column by these values: hibernating, need attention, loyal customer, champions, based on the value that has been present in this column. Okay, so basically it's creating 4 categorical data. Now you can see here, by the use of this Python statement clv.head, now we have actually an overview of our data set. Now we can see that the data has been segmented, and our customers have been segmented based on this customer lifetime value. That's how. And finally, after when we have done that, let us calculate the mean or average value of each category. So we are going to calculate the mean values of frequency, recency, time, age, monetary value, what is their expected purchase in 6 months, and what is their customer lifetime value. So we are calculating this by using group by method. We are applying group by method on segment, and we are calculating the mean value. So we have hibernating, need attention, loyal customers, and champions. And that's how you can actually calculate this value or customer lifetime value for a specific segment of customers. That's it for now. I hope this tutorial have been helpful. If you have any question regarding today's tutorial, feel free to write down your comments. I will be happy to help you out. I will be publishing more videos regarding data analysis and marketing analytics, and as well as I will be publishing tutorial videos on regarding R programming and MATLAB programming. So I request you to subscribe to my channel and hit the notification bell icon button. I will soon catch you in the next video. Thank you for joining me.